Hello friends, today we shall study about pointers in C, which is one of the most critical topic in C. What are pointers? How can we define a pointer? We can define a pointer as a variable that stores address of another variable. What is a variable? Variable is a named memory location. That means every variable has an address. And if we want to access that address and store it somewhere, we will require a pointer. Let us see an example. Let us see this part of the code. Let me highlight it. Let me use this. I think this is pretty well readable. Let this be the color. Let x is equal to 0. What I am doing here, I am assigning the value 0 to a variable x. Now, address can be retrieved by putting an ampersand before a variable name. What happens if I put this ampersand? What is ampersand? When I put the ampersand operator before a variable, it gives us the address of that variable. In fact, this is called an address of operator. All right, address of operator placed before a variable will give us the address of that variable. But what if we want to store that address? All right. So suppose we want to store the address of x in some particular variable. Now we cannot do so in ordinary variable. All right. If you want to store the address of a variable, for example, if you want to store the address of x, which is ampersand x, it is not possible to store it in an ordinary variable. We have to use a special type of variable, which is known as pointer variable. For example, int star y. Here y is a pointer variable of integer data type. And in it, we are storing the value of v. Not value of v, we are storing the address of v. Values can be stored in ordinary variable. When we want to store the address, then comes the use of pointer. Now, pointer declaration. How do we declare a pointer? Give the data type of the pointer, then use the star, that means the asterisk, which we in common language call star, but use the asterisk symbol and then give the name of the pointer variable. For example, in star p, here p is a pointer variable of integer data type. And similarly, ptr2 is a pointer variable of double data type. Now, what is the significance of the data type of a pointer? Does it determine the size of the pointer? Does it work like a variable? The answer is no. It has a deeper significance. Let us study here. Pointer initialization. Here is a program where we have taken a variable a of integer data type and initialized it to value 10. Again, we have taken a pointer p. Now, in the third line, what we are doing? In the third line, this particular line, what we are doing? In this particular line, we are assigning the value of a, not the value, the address of a in pointer p. Now, if p was some ordinary variable, this could not have been done. Because p is a pointer variable, it is able to store the address of a in it. And finally, when we are printing p, what we will get? We'll get the address of x. All right. And when we print star, that means asterisk p, what we shall get? We shall get the value which is stored in a. You see, these two operators, asterisk and ampersand. Ampersand means address of it. If we place ampersand before a variable, it gives us the address of that variable. If we store that, if we want to store that address in some variable, we require a special variable which is known as pointer variable. Now see, this asterisk is very interesting. When we are using data type before the variable, when we are using data type before this asterisk, it makes p a pointer variable. However, if you are using asterisk p instead of data type, then it will give the value at location p. What is at p? We have the address of a at p. So what we are getting here, we are getting the value at P, which is asterisk ampersand A, which ultimately gives us A. That means the value of A. Pointer types, null pointer. We can create a null pointer by assigning null value during pointer declaration. Let us see here. What I have done here, I have declared a pointer PTR of integer data type and assigned it null. You see, in the previous program, what we did? In previous program, we assigned the value of X to Y. So pointer Y had a genuine address. But suppose pointer, we don't want to give an initial value to pointer. So we can simply declare a pointer. In that case, what will happen? It is a wild pointer. That means it is not pointing to anything. And pointer can be dangerous thing. All right. Pointer is a double, it is double-edged sword. All right. It provides a lot of benefit, but it can be very dangerous also. If not used properly, it can create a lot of problem. So it has to be handled carefully. In small program, it is all right, but if we are writing, if we are creating massive projects, the wrong use of pointer will play havoc. So its use must be proper. So here is a PTR is a pointer. We have initialized this to null. And now when we are printing this P, what we will get? Let us see what we get. All right. Okay, I will explain it later. First, let us proceed. Void pointer. What is a void pointer? A void pointer is also called a generic pointer. You see, generic pointer. This generic programming has become very important in present world. All right. This is the generic pointer. For example, you see, we have used void star PTR. All right. Now we haven't given the data type of this pointer. We have initialized it to null. We have it, but haven't provided data type of PTR. So what type of address means address of which type of variable can PTR store? Let us see. A void pointer is also called a generic pointer. It does not have any standard data type. A void pointer is created by using keyword void. It can be used to store an address of any variable. All right, this is its importance. It is generic. That means it can accept address of different data types. Wild pointer. A pointer is set to wild if it is not initialized to anything. You see, int PTR, we haven't initialized to anything. Now, what does it contain? It doesn't contain any proper address, so it is regarded as a wild pointer. Some other pointers are, which I will just simply mention, but I will not deal with. I'm not dealing with it in this video. Later on, we'll deal with it. Other pointers are dangling pointers, complex pointer, near pointer, far pointer. All of them are important, but they are not the topic of discussion in this video. Now, direct and indirect access pointers means, let us see this with an example. Suppose I have created variable v of integer data type and initialized to 1. P is an integer pointer, and here is the main function. What is this line doing? We are placing the value of variable v in pointer p. P is equal to ampersand v. Let me highlight this program, or let me make it bold. So what we are doing? Ampersand v, address of v, I am storing it in p. All right. Now, if I print v, what will happen? I will get the value 1. Now, if I print star p, what will happen? Asterisk p. That means actually this is value at operator. So what does p contains? It contains the address of ampersand p. So it exactly what is happening here. You see, it is like that value at it is like this star. We can replace p with ampersand v. So the whole statement is like this: value at address of v. So what is value at address of v? We'll get the value 1. And when we print ampersand v, what is this? This is the address of v. And when we print v, again we'll get the address of variable v. All right. Now, next thing which we'll study is the different operation which is possible on a pointer. You see, we can increment or decrement a pointer. We can add a number to a pointer. That means we can add an integer to a pointer. We can subtract a number from a pointer. We can subtract one pointer from another. We can compare two pointers. These things are possible on pointer, but what is not possible on pointer? We cannot add two pointers. Obviously, pointer cannot be divided and multiplied. All right. And this pointers and array, these pointers and array and pointers and strings, all these are critical topics, and we will deal with it in later videos. All right. Now, I will explain the concept using a program. This program, I previously mentioned it, but now we will run it. All right, run in DeepSeek compiler and see what is the output. So as I explained earlier, v is a variable which has been initialized to 1, p is a pointer. In the pointer we have placed the value of, we have placed the address of v, and finally we have printed all this. Now let me first execute this program. Run. Here is our output. Let me place these two things side by side, and so it will be possible for me to demonstrate, explain it. Yes, now it is possible. You see, first we are printing v. What is the value of v? 1. Then we are printing asterisk v, value at p. What is value at p? As I explained here, you see, value at p means value p contains ampersand v, that is address of v. That means value at address of v, which again is 1. Ampersand v, we are getting the address. We are getting the address of v. P, again p is equal to ampersand v, again we are getting the address. Now, some, you see, students may ask, or this question comes in everybody's mind, that what exactly is this address? Let us count how many bits, how many numbers are there. 1, 2, 3, 4, 5, 6, 7. All right. 1, 2, 3, 4, 5, 6, 7. 4 sevens are 28. So what is the address? What is the exact address? Is the real address? Is this the real address in RAM? You see, if you run this program in Turbo C compiler, you will get a different sort of address. So what exactly is happening? Does pointer in C reflect the real address, or is it something else? Well, those are the topics which I shall deal into the next video. Okay. Thank you.